Okay, so now we're going to cover, get into proteins, but before we talk about proteins, we're going to talk about another functional group called amines and amides. Amines are organic compounds that have nitrogen in them. They look like ammonia, NH3. Amine is basically an ammonia group that's attached to a carbon. There you go. And there should be a carbon here. It'll attach to a carbon. All right. So all amines will have carbons. Will have nitrogens attached to a carbon. There's different types of amines. There'll be primary, secondary, and tertiary. And like alcohols, when we covered alcohols, you can have primary, secondary, and tertiary alcohols. And you can have the same with amines. A primary amine is an amine with a nitrogen that only has one carbon attached to the nitrogen. Okay. You won't have to name these, but we'll go through how. Well, you may. So we're just fairly simple to name them. So what you do is basically you just name what group is attached to the nitrogen. So this is a methyl, and this is amine, so it's methylamine. Okay, here's another primary. This would be called ethylamine. Okay, this nitrogen only has one carbon attached. These hydrogens are actually attached to the carbons on each side. So this carbon is attached to nitrogen. So there's only one carbon attached. So this is a primary amine, and we call it ethylamine. Okay, secondary amines the nitrogen will have two carbons attached to the nitrogen. And again, they're fairly simple to name. You just name who's the groups. This is ethyl and this is a methyl. So it's called ethyl-methylamine. All right, this is also a secondary amine because there's a nitrogen with two carbons attached. This would be dimethylamine. Notice the nitrogen has a lone pair on a nitrogen. At the beginning of the semester, we talked about nitrogen has 3 bonds and 1 lone pair. So it has 1, 2, 3 bonds and 1 lone pair. While carbon has 4 bonds. So 3 of these are attached to hydrogen and 1 attached to nitrogen. All right, and finally there's something called a tertiary amine. A tertiary amine is a nitrogen attached, has 3 carbons attached to it. And again, it's fairly simple to name. This would be trimethylamine. This is also a tertiary. It has 2 methyls and an ethyl, so it would be an ethyl dimethylamine. Okay. Amines are organic bases. A base is a substance that can accept a hydrogen ion in water. Carboxylic acids are acids, and they will donate a hydrogen in water. We didn't go over the acid-base theory all that much, but just be aware of these statements here. Okay, one of the places where we find amines in nature are drugs, both pharmaceutical and illegal drugs. Okay, you may have heard some things like these guys here. So here are some common drugs with amines: nicotine, cocaine, morphine, quinine or quinine, codeine, atropine, epinephrine or epinephrine, adrenaline, and amphetamines. Okay. Notice they all end with INE and have the "ine" name to them. just about every pharmaceutical drug out there will be an amine. And here's some examples of these drugs. Okay, so Sudafed, probably all heard of that. Okay, and it's an amine. Here's the amine group, and Benadryl over here. It has a amine group over here. And if this was a in phase class, I'd talk more about these and their structures and how they're interesting. Okay, here's cocaine, structure of cocaine. Has the amine group. Okay, and you notice it has this like little saddle group on it. Actually, it's really important to how cocaine works. It also has an ester group. See this? It's an ester right here. And here's another ester. But the name cocaine comes from the amine group. And nicotine and quinine. Heard of nicotine? Caffeine. Okay, caffeine has quite a bit of amines. It has amine here, 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 and here. And when we get to nucleic acids, we will see the nucleic acids bases look very similar to caffeine. And that's actually a very important reason why caffeine will kind of keep you awake and kind of give you energy, even though it doesn't really give you energy. There's quinine, which was found used for malaria. And atropine, which is, I'm not really sure about it, but I know I've had nurses in my class that have known its uses before. So you may have been aware of this guy, atropine. And then there's morphine and codeine, okay, both with pain relief, and notice they look quite a bit same. They have amines as well. A big amine that's getting a lot of attention these days is hydroxychloroquine, okay, which is Trump wants to get this out to the public because he thinks it's going to cure our problems with the COVID virus. But here's the amine, here's an amine, here's an amine, and here's amine. The hydroxy means it's because of this OH. The chloro is because of this Cl down here. Okay, now on to amides, or amides. And amides are going to be, they'll have a carboxyl group and an amine attached together. Now when we talked about esters, an ester was a carboxyl and an oxygen. So you can see amides and esters look quite a bit. So an ester would have an oxygen here instead of a nitrogen. And you're going to see how they are related in a second. Okay, these are very interesting because we're going to find that proteins are basically amides. And how the proteins are made of amino acids, and the amino acids are connected by the same way that amides are produced. And what we're going to do is go over how you form an amide, and then when we talk about proteins, you will see the same type of reaction as it applies to proteins. Okay, this type of reaction is called amidification. And you take an amine and a carboxylic acid. Okay, notice we covered this reaction here, esterification, in the last chapter. You take an alcohol plus a carboxylic acid, snap off the water, connect the alcohol to carboxylic acid, and you got an ester. Okay, so you see this oxygen trapped between the two carbons, and you have this oxygen, and you make water. And that bond is called ester bond. Okay, for amidification, it's a similar type of reaction. instead of having oxygen here, you have nitrogen. The hydrogen pops off, combines with the OH of carboxylic acid, forms water. And then these two guys connect to form an amide. Okay, an amide, notice it's N, nitrogen with a carboxyl. This type of bond is called an amide bond. Okay, so that's it for these two guys. So we're going to see in the next slide shows how amines and amides play in the structures of proteins.